In this lesson we are going to look at surds. Now I'm not going to pretend that surds have any actual function outside of your maths GCSE lessons because they don't. They're fucking stupid. But unfortunately they're likely to appear in your tests, so we're going to go through the surd rules right now. Okie dokie. So the first rule is about how we multiply surds together. So if we have something like the square root of x multiplied by the square root of y, that is exactly the same as saying the square root of x multiplied by y. So for example, if we had the square root of 2 multiplied by the square root of 4, that is the same as saying the square root of 2 multiplied by 4, which of course is the square root of 8. The second rule we have on surds, so we're going to call that rule number 1. Rule number 2 is to do with fractions, and if we have the square root of x divided by the square root of y, that is exactly the same as saying the square root of x over y. Sorry about fucking starting again. So if we had something like the square root of 3 over this, oh no, let's see if I can make this a little bit more, no fuck it, I'll just do this. Square root of 2, that is the same as the square root of 3 over 2. So we could see this in a question because we could see something like the square root of 8 over the square root of 2, and it may say simplify. So in this case we know that that is also the square root of 8 over 2. The square root, 8 divided by 2 is of course 4, so that equals the square root of 4. The square root of 4 equals 2. So that's the example of how they could put that in a question. Rule number 3, oh bugger. Rule number 3 is when we have things like plus and addition. So we've already said that if we have the square root of x times the square root of y, that equals the square root of x times y. Remember, we have two things like this together, there's an implicit multiplication symbol there in the middle. But if we had the square root of x plus the square root of y, that does not equal the square root of x plus y. Not. No, it doesn't. It's a different fucking thing, so don't do that. It just stays like that. Rule number 4, so this is when we've got something and there is an exponent on the end of it. So say we've got square root of x plus the square root of y all squared, and this is exactly the same as expanding brackets. So obviously we've got that bracket multiplied by itself, so that is the square root of x plus the square root of y, and then again multiplied by itself, so the square root of x plus the square root of y, and then we expand that as we would normally. So square root of x multiplied by the square root of x is x. Square root of x multiplied by the square root of y is just root x root y. Of course it's also root x y, depends how you want to write it. Square root of y multiplied by the square root of x is the same thing. Square root x, square root y. Of course that could also be square root of y first, square root of x second, it doesn't make a difference. And then finally square root of y multiplied by the square root of y equals y, so that would be x plus y plus 2 root xy. Now the final rule in these is to do with irrational fractions. Now an irrational number is one that goes on and on and on and on. So if you put something like the square root of 2 in your calculator, you'll see a number that looks like 1.4 blah 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 blah, and it goes on for infinity. So a number that goes on for infinity, no repeating numbers, we call that an irrational number. So if we had a fraction that was x divided by the square root of b, and b wasn't a squared number, so if b happened to be something like 25, we know the square root of 25 is 5, that would then be a rational fraction. But if b is a non-squared number, so it could be something like 10 or 13 or 378, doesn't really matter what it is, the square root of that number would be irrational, and what we don't want is an irrational fraction. So what we need to do is we need to multiply both the top and the bottom by the square root of b. Now this doesn't actually change our fraction numerically, because if you think we're multiplying it by square root of b over square root of b, anything divided by itself is 1, so all you're doing is effectively multiplying this by 1. Anything multiplied by 1 is itself. However, it changes our fraction, because then we have x multiplied by the square root of b on top, which we just write like this. Of course you can write x times square root of b, but it looks stupid and people think you're an idiot. And on the bottom, the square root of b multiplied by the square root of b is of course b. And now we have a rational fraction that has the same value as our original fraction. Put an equal sign in there. So yeah, that's a really key thing I don't think I mentioned. The square root of x times the square root of x equals x. And that holds for any number. It's definitely one worth putting into your calculator and trying. I'll do a separate video now where I'll run through a number of different example questions.